Welcome to Study Loop.
Okay, so for this question, we can use the maximum intensity equation, which is A sine theta is equal to m lambda. Lambda is the wavelength, m is just the number, sine theta is the sine function, and A is the width of the slit. Therefore, we have tangent theta is equal to omega divided by 2 over x, which is equal to omega divided by 2x. Okay, it's shown in the graph here. So the x is the distance between the screen and the slit, and omega is the distance on the screen between the two minima on either side of the central maximum. Okay, so since the angle theta in this question is very, very small, that means sine theta is approximately equal to theta, which is approximately equal to tangent theta. So therefore, we have sine theta is equal to omega over 2x. Then we have A times omega 2x is equal to m lambda. So A omega over 2x is equal to m lambda. Then we have A omega is equal to 2x times m lambda. Let's say that m is equal to 1, so we have A omega is equal to 2x lambda. And as you can tell, A omega is equal to some kind of constant, which is 2x lambda. And this is the graph I drew for this question, which is the graph A omega versus A. And as you can tell, AW is not constant when the value of A is small. But as the value of A increase, you can tell that the value of AW is approximately constant. Okay. So therefore, let's jump to question B. Well, we know AW is equal to 2x lambda, so therefore lambda is equal to AW over 2x. And based on the graph and the table that was given from the question, AW is equal to 1.56 times 10 to the power negative 6 meters squared. Okay. And then x, which is the distance between the screen and the slit, is 1.50 meter. So therefore, we can determine the wavelength of the laser lights, which is equal to 1.56 times 10 to the power of negative 6 meters squared over 2 times 1.50 meter. And this will give us 5.2. Oh, sorry. 5.2 times 10 to the power of negative 7 meter, which is 520 nanometer. Is because 10 to the power of negative 9 meter is equal to 1 nanometer. Okay. And for question C, well, we have two different cases. So for the first case, for the first angular position, we have A sine theta is equal to m lambda. So therefore, sine theta is equal to m lambda. Okay. So let's say sine theta 1 is equal to m lambda. And in this case, you were saying that the first minimum, so therefore m must be equal to 1. And we already know the wavelength is 520 nanometer, which is 5.2 times 10 to the power negative 7 meter. And we know A1 is given as 0.78 micrometer, which is 7.8 times 10 to the power negative 7 meter. So we can plug it back to the equation to determine the sine theta 1. So if the sine theta 1 is equal to 1 times 5.2 times 10 to the power of negative 7 meter over 7.8 times 10 to the power of negative 7 meter. And this will give us sine theta 1 is equal to 0.667. So therefore, theta 1, let me see. So theta 1 is equal to inverse sine function of 0.667, which is sine to the power of negative 1, 0.667. And this will give us the angle is about 42 degrees. So this is the first angular position we have. And for the second case, we have sine theta 2 is equal to m lambda over A2. So it's talking about first minimum, so m equal to 1. And lambda is the same, and A2 in this case is given as 15.6 micrometer, which is 1.56 times 10 to the power negative 5 meter. So therefore, we can determine sine theta 2, which is equal to 1 times 5.2 times 10 to the power of -7 meter over 1.56 times 10 to the power of -5 meter. And this will give us sine theta 2 is equal to 0.033. Okay, so therefore we'll have theta 2 is equal to inverse sine function 0.033, which will have the angle is about 1.9 degree. And these are the answers for this question.